Okay, another example. So the question gives you a y, and what y is, it is I'm going to change the question just a little bit, okay? So this would be, let's say, x squared plus parenthesis 1 plus sine squared x to the 4. Actually, let me not change that much, okay? So let's maybe you want to see if your answer is correct. So maybe I'll just do it as it is. 3. Okay, that's the question, right?
Let's do this sine squared x to the 6, and then on the outside of the brackets, let's do it 4.
Yeah, I think it's going to differ from people to people, those numbers.
Okay.
But I think the x plus sine squared x, that remains the same for everybody, okay? All right, so okay, so how do I find the question is, I want to find the derivative, right? I want to find the derivative. So what is dy dx? That's the question. Okay, so how would you do this problem? Well, first of all, when you look at this function, you should say that, well, I have a function where I have certain quantity to the power 3, right? So the last possible bracket here, right, is you have certain quantity to the power 3, right? Can I view it that way? Okay, so if the quantity inside the brackets were just x, how would you find the derivative? If the quantity inside the brackets were just x, you would just apply the power rule and say that it is 3 times x squared, right? So assume that the quantity inside the brackets is just x. So if I assume that, then the derivative is what? The derivative is 3. The quantity that I am assuming is x, right? And that is x plus sine squared x to the power 4. So the quantity inside the brackets, I'm assuming that's x, and assuming that that is x, this is the only derivative, right? But however, the quantity inside the brackets is not just x, so I have to take the derivative of that and multiply. So I have to take the derivative of the quantity inside the brackets. So this is x plus sine squared x to the 4. Again, I'm showing you as many steps as I can. You don't have to show all this. You can do it in one line if you want, if you can. So this is x plus sine squared x to the 4. And how do I find the derivative of that? Well, so this is going to be then 3 times x plus sine squared x to the 4 squared. And then now I'm taking the derivative of the quantity inside the brackets. Well, I have 2 terms, right, inside the brackets now. 2 terms. I take the derivative term by term, right? I am allowed to take, if I have a sum, I can take the derivative term by term. So what's the derivative of the first term? 1. So now I have 1 as the derivative of the first term, and then plus I have to take the derivative of the second term. Now what's the second term? The second term, I have certain quantity to the power 4, right? Certain quantity to the power 4. So the quantity inside the parenthesis here, the quantity inside the parenthesis is x plus sine squared of x. If that quantity were just x, how would you find the derivative? So now we are taking the derivative of this guy, right? We are taking the derivative of x plus sine squared x to the 4. The quantity inside the parenthesis, if it were just x, then the derivative can be found easily by the power rule, right? So the derivative would be 4x to the 3, right? That's the derivative if the quantity inside the parenthesis were just x. However, it's not just x, so you have to take the derivative of that and multiply, right? So what's the derivative of the quantity inside the parenthesis now? 1 plus the derivative of sine squared, right? So let me write it here. So I am multiplying, right? Multiplying 1 plus the derivative of sine squared x, right? Let me remind you that what's the meaning of sine squared? Sine squared means sine of x to the power 2, right? That's the meaning of sine squared x. So what's the derivative of that? Again, yes. So you take 2 sine x times cosine x. Again, sine x to the 2. So assuming sine x is just x, the derivative would be 2 times sine x. But then you have to multiply by the derivative of sine x. So that's 2 sine x cosine x. And I think I am missing a bracket here, right? Is everybody here? Alright, so there isn't really much to simplify out here, okay? Yeah, you just want to leave it as it is. Okay. One thing I want to mention here that sometimes WebAssign may not like this notation here. Yeah, instead of writing sine to the power 2x, you might want to write sine x brackets to the 2. Am I making sense? So this is, I think the WebAssign prefers that. It doesn't prefer this. So if when you're typing out your answer, you might want to do that. Okay. Michael, does that answer the question?
Do we just leave it like that then? Or do we need to simplify it for WebAssign?
I would have, if I could have multiplied some of the constant factors, I would have, but there is only 3 there. Otherwise, I wouldn't try to see. There is nothing I can factor out here, and multiplying it out is going to be tedious and doesn't really make it anything. I mean, multiplying out, will it make it look better? And my answer is no. So just leave it the way it is. And I think WebAssign will also look for this answer. Okay. Is that okay? All right. Okay, so that's any other homework problems on derivatives that you want me to answer? It's the same thing. I was trying to review derivatives. So doing some of those problems is the same for me to review. So if you have any other, let me know. Okay, so let me go on. I was actually trying to do problems similar to your homework problems. Okay, let me move on then. Another example. So I did a problem with product rule and chain rule, right? Together. The last one was basically just the chain rule, right? Didn't use really product rule. I want to do a problem where I have to do a quotient rule, okay? So let's look at one of those. And this is a problem that I think I asked in one exam last semester. x squared plus 1 over x squared minus 1 to the exponent 5. Okay? And you have a web assigned problem very similar to that. Okay, so in this case again, I want to find what is the derivative. So what should I do in this case? Should I be thinking about applying the quotient rule right away? No. You have certain quantity to the power 5, right? Certain quantity to the power 5. So if that quantity were just x, what would be the derivative? If the quantity, the fraction were just x, you would be getting, the derivative would be 5 times x to the 4. That's the derivative if the quantity inside the parentheses were just x. But it's not x, so you have to multiply by the derivative of that. And so now you take the derivative of that fraction, right? Now you think about the quotient rule. Okay, so now I'm trying to find the derivative of the fraction. What's the derivative of the fraction? Well, I have to do what? Can someone tell me the quotient rule? Or you can sing the formula to me. Okay, so you have what? So what you do is in the denominator, you square the denominator, right? Square the denominator. Okay, so that's what she meant by low. That is, you're taking the denominator times itself, and in the numerator, what you have is low d high. That's what she said, which means the denominator multiplied by the derivative of the numerator. So what's the denominator? The denominator is x squared minus 1, and then you multiply that by the derivative of the numerator. The derivative of the numerator is 2x minus, now you do the opposite, you have the numerator, and then you multiply by the derivative of the denominator, which is 2x. Is everybody okay with that? Okay, so you can simplify out here. So this would be okay, so let me do this. So I'm going to write this as 5x squared plus 1 to the 4 divided by x squared minus 1 to the 4 times, okay, so let's multiply out here. You get 2x cubed minus 2x minus 2x cubed minus 2x, okay, divided by x squared minus 1 squared. Is everybody okay with that? Alright, so what am I left with? So this would be 5x squared plus 1 to the 4 divided by okay, let me keep it as it is for now. And what am I getting here? Am I getting just negative 4x? Okay, so finally what I'm going to do is a negative 4 and a 5 would be negative 20 x squared plus 1 to the 4. In the denominator I will write x squared minus 1 to the you add the exponents, right? Everybody's okay? Alright, so I'll just leave my answer right there. Is everybody okay with that? Okay, so that was chain rule, and then you applied the quotient rule. Yeah.
Can you do a problem like
Number
number 9?
9. How about I just do number 9? Okay, so this is a problem from your web assigned homework. It says that h of x is equal to the root 4 plus 3 times f of x, and you are given that f of 1 is 4. You're also given f prime of 1 is 2. And okay, so that's it. The question is, what is h prime of 1, right? The question is, what is h prime of 1? So that's the quantity that you need to find. Okay, so well, basically you have to find the derivative of h, right? So what's the derivative of h? Well, the function h is given to you as the root of 4 plus 3 times f of x. And I'm going to rewrite that function as 4 plus 3 times f of x to the half. Right? That's the function. 4 plus 3 f of x to the half. So you have certain quantity to the exponent half. If the quantity inside the parenthesis was just x, then you have just x to the half, and the derivative would be what? Half x to the half minus 1, right? But the quantity inside the parenthesis is not just x, so you have to do what? Multiply by the derivative of that. So what's the derivative of the quantity inside the parenthesis? Well, the derivative of 4 is 0. And what's the derivative of 3 times f of x? Yeah, this is just 3f prime of x. You don't have a formula for f, so you just write f prime, whatever that is. Now we plug in 1. So what is, well, before I plug in, let me simplify one more time. So 3 half, you realize that what I'm going to get here is 1 over 4 plus 3 f of x, root of that, and in fact let me write f prime of x on top here. You realize I can simplify it that way. Half minus 1, that's a negative half, so if you negative half, you put it in the denominator as a positive exponent half, and that's the same as the root. So all I have to do now is plug in. So what is h prime of 1? Remember, that's what we needed to find. And so this will be 3 half f prime of 1, 4 plus 3f of 1. Do we know f of 1? That's given in the question. F prime of 1 is given in the question. And now we just have to plug those in. So what is that? 3 half. Question says f of 1 is 4. F prime of 1 is 2. 4 plus 3 times 4. And what are we getting? What is 4 plus 3 times 4? 16. So that's 4 I'm getting, right? So what is that? 3 over 4, right? 2 and 2 cancels out. So you can cancel out these two, and you're left with that. Okay? Michael, was that okay?
Yeah.
All right. Any other questions, anybody? I want to then continue with other problems that I wanted to do. Suppose that I have y equals to secant squared x. Okay. And what I want to know is the second derivative of this function. Okay. So what's the first derivative? The first derivative would be I have to think of this as secant x to the 2. So by the chain rule, I know this would be what? 2 times secant x, and then you multiply by the derivative of secant x, which is what? Secant x tangent x, and you can simplify that as 2 times tangent x secant squared x. Okay. And now, what's the second derivative? Remember the notation for second derivative? So the second derivative of y with respect to x, right? And well, that means that I take the derivative of the derivative, right? Take the derivative of the derivative. Now, how should I view the derivative function now? Well, I am going to think of this as 2 factors like this. Okay? And now, what's the derivative of the first factor? The derivative of the first factor is what? Yeah, the derivative of tangent is secant squared, but you have to keep the second factor as it is, plus the first factor as it is, and then you multiply by the derivative of the second factor. But remember, we already computed the derivative of secant squared, right? This is exactly the derivative of secant squared, right? Remember that? So the derivative of the second factor I have in front of me. I don't have to think about anything else. It's 2 times tangent x secant squared of x. Okay. So basically what you have is 2 secant to the 4x, because you're adding the exponents, right? Plus 4 times tangent x, tangent squared x, right? Times secant squared x. And if you want, you can factor out a 2 and the secant squared x, and that's going to give you secant squared x plus 2 tangent squared x. Everybody is okay? Well, I did this problem just to remind you of second derivative. You can take the second derivative. Now if I ask you to find the third derivative, you can also do that, right? You can find the third derivative by taking the derivative of the derivative of the derivative, right? So you take the derivative of the second derivative. That's what I mean. Okay. Let me see. Let's do something like implicit differentiation, okay? implicit differentiation, let's say I have the following. Let's say I am given a equation which is x cubed plus y cubed equals to 6xy, and you guys remember implicit differentiation, right? So this equation has certain graph, right? Whatever the graph is, doesn't matter. This has a graph, and the graph of an equation usually does not represent y as a function of x. Okay, usually doesn't represent y as a function of x. Why? Because maybe there is the same value of y may be associated with two distinct values of x. That's why the graph may not represent y as a function of x, right? You realize that? Because the same value of y on the graph may correspond to two distinct values of x. Okay? That is, it's not going to satisfy the vertical line test, right? Okay, but if you have a graph, if you have a curve, you can imagine that part of the graph will represent y as a function of x, right? For example, if you have the circle, it doesn't represent y as a function of x. However, if you just take the upper half of the circle, then it does represent y as a function of x, right? That's what I mean. Even though the graph of this equation doesn't represent y as a function of x, some parts of the graph may represent y as a function of x, and there is more than one, right? Usually there will be more than one. You can find more than one parts of the graph that represent y as a function of x. The question is, how do you find the derivative of that function y? And the answer is you use implicit differentiation. So here, so what do we do? Well, we take the derivative of both sides, right? So I take the derivative with respect to x of x cubed plus y cubed, and I also take the derivative with respect to x of 6xy. Okay, so what's the derivative of x cubed with respect to x? Yeah, so let me actually write one more line. So I have this plus with respect to x of y cubed, which is the derivative with respect to x of 6x times y, right? Of course, the derivative of x cubed is going to be 3x squared, as you said. Okay, plus, now you're taking the derivative of y cubed with respect to x. Now, you have to keep in mind that you are viewing y as what? Y is a function of x. You're assuming that y is certain function of x. So you have to think of it as certain function of x cubed, right? Certain function of x to the power 3. So think of y as sine x or something else, okay? Y of x. And then what's the derivative? Well, if y was x, right? If y was x, what's the derivative? Yeah, if y were just x, the derivative would be 3y squared, right? But y is not x. Y is some function of x. So you have to multiply by the derivative of that, by the derivative of that y, okay? On the right hand side, I have two factors. One is 6x, the other factor is y, right? Again, y is a function of x. So you have to apply the product rule. By the product rule, you take the derivative of the first factor, which is 6, multiplied by the second factor as it is, plus the first factor as it is, multiplied by the second derivative of the second factor. The derivative of the second factor is y prime. And so basically now I have to solve for y prime. And so that's the next difficulty. Usually the mistakes that I see in exams is on the right hand side. people forget to apply the product rule. Okay. Now, how do I solve for y prime? Well, you just combine those two on the left, and combine these two on the right. So what am I getting? I'm getting 3y squared y prime minus 6x y prime equals to 6y minus 3x squared. And here then I can factor out y prime, so I get 3y squared minus 6x y prime is 6y minus 3x squared. And now I can find y prime by saying this is 6y minus 3x squared over 3y squared minus 6x. You guys agree with that?